Hey everybody, this is Larry. This is me doing week 1 of the weekly Leetcode Premium Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Today we have 1199 minimum time to build blocks. It's a hard problem, so let's get right to it because it's hard. You're given a list of blocks where block sub I is equal to t, or where block sub I is equal to t means that the ith block needs t unit of time to build. A block can only be built by exactly one worker. A worker can either split into 2 workers, the number of workers increased by 1, or build a block then go home. Both decisions cost some time. Okay? The time cost of splitting 1 worker into 2 workers is given as an integer split. Note that if 2 workers split at the same time, they split in parallel, so the cost would be split. So you always so it always just doubles, right? Okay. Because they don't incur additional costs. I'll put the minimum time needed to build all blocks. Initially, there is only 1 worker. Okay, let's see. Right, do I have to do them at any given time, or what does that mean? Like, do I have to do them in order? I guess is what I'm trying to say. Doesn't seem like it. My question is maybe we could sort them. I don't know. 1000 is interesting, maybe, but okay. Oh, a worker can split into 2. A block can only be built by exactly 1 worker. Okay. So the cost is 1 plus max of 3, and then split a second one. Wait, what? I see. Huh. Then that's not a lot of blocks. That's just each block can be long. Okay. I mean, this is hard. I guess we will see. Split cost can only be 100. Don't know if that is any relevance there. My first guess would be some sort of binary search. Right? In a sense that I have some principles, right? In that if you want to split into k workers for some number k, you always want to split at the earliest time possible, right? And that's like the repeat doubling, and by that I mean just in the beginning. You keep on splitting until you have k workers, and then you do the math on the k workers. So that should be binary searchable, I think, right? Because the more well, I mean it's maybe not binary search in the traditional sense, but because you have this thing, a curve, right, where you have a curve where if you don't have enough workers, it's going to take a long time. If you have too many workers, you spend too much time splitting, right? So it's somewhere in the middle. So that makes me say that there is a binary search, or at least like some sort of bisection or something like that. But forget how that goes. Actually, I mean, you just have to take a slope or something. But I don't know if that's quite right. I think that what I'm trying to do is also take advantage of the n is equal to 1000. I'm confused. Oh, you build a block and go. Okay, so actually, no. Let me take a step back. I was confused because I read this wrong. I was confused because I was looking at example 2, and I was like, well, I don't know how that works because, or I don't know why you would split because you just take one person, one worker, and then do both of them, but you cannot. So you need k workers, right? I don't get. So you always need k workers, so it doesn't make sense. So you need exactly k workers. So is this just an algorithm or how? I don't. Oh, I see. So the problem would be because I'm trying. So some of it is like in a meta sense because I'm like, well, if you only need exactly k workers, what we said about binary search is obviously not true. But it also means that you know exactly what k is, right? Because you need one worker for each block, which maybe is an obvious thing, but we read it wrong. We came from the wrong direction, right? So okay, you need one worker for each block. And then the idea is that, okay, well, what you do first, is it just not greedy? Would you not do greedy first? I guess the idea is also try to figure out when you want to split. I mean, maybe for k is equal to 3, it doesn't make sense. But for example, you can imagine you have like k is equal to 10. I don't know. You could say 1 goes to 2, and then start on 1. And then 2 goes to 2 because one of the person goes, because one person splitting, 1 split plus 1 get on a job, and then you have 2, and then you do it again, right? And then the other obvious case is that you go 1 to 2 to 4 to 8 or something, right? To 16 or whatever. But I think, okay, so those are the two ideas or two strategies, right? I mean, it's or 2 ideas, not strategies, because you may not necessarily do it this way. You could have some hybrid thing, right? Where, okay, you have one really expensive job, so you get to start it as early as possible, and then the rest you do this doubling thing or something like that. So it's a hybrid between both. So you have a decision there, right? And obviously 16 is greater than 10. I just kind of wrote it as an illustration. And then the idea is, well, the other core idea is still that no matter how you split it, assuming that you have an optimal split, you always want to do the heaviest block first, right? The most expensive block first, because, well, the earlier you get that, the better, right? So we want to sort, maybe reverse is equal to true, right? So that I think we can do, and then we can just do. So then at that point, because, well, you know, number of workers is equal to the number of blocks, and this is where the k or n is equal to 1000 comes in, because then now this is a dynamic programming problem, right? Because you can do index and workers, right? And what that is for a DP problem is index is the block sub-index that hasn't been done yet. You could write this in a number of ways. It just means that, like, you know, you're taking the suffix of blocks to solve as a sub-problem. You could say that we finished the first index things. It's all kind of equivalently. And then workers is just the number of current workers. We can double if we want. Do we want to double always? Huh. Because that is the tricky part, right? Because the thing that I'm saying is a little bit tricky is because initially I thought I could convert this into a tick, no tick, right? And maybe I still can. But it's not quite as simple, because here, if we have, I'm trying to think whether it would make sense ever to split up 2 workers instead of, like we have here, we split up 1 worker, or one get on a job and 1 split, right? But maybe 2 gets on a job and then the rest split or something. And then, but if you're going to do it that way, then you now have a for loop, right? And if this is, because initially my thought process is that this is 1,000, this is up to 1,000. Well, I mean, it is 1,000 and this is 1,000, but it's not or not all 1000 is possible, right? Because for example, if index is the last, or if index is the first index, you only have one worker, so that means that all the other space is not possible. But that fills up pretty quickly, maybe, right? So I don't know. So if you add a for loop there, then it's going to be 1000 cube, and that is just, well, maybe not so good. Okay, so that is. I mean, maybe we could YOLO it anyway, but on a cursory look, it doesn't look right. And then the question is also, can I have cycles? No, because anytime you use a worker, you go down. Right. Or the index goes up. I mean, workers obviously go down, but so you're only going down on this. Okay. Alright, I'm not gonna lie, I need to pause, I need to use the restroom. I'll be right back. I mean, to you it'll be nothing. Alright, I'm back. Alright, let's think. I mean, yeah, like I was saying, you know, let's just write out the naive way, and then we'll see if I spot anything, because that's how I usually do it. So index is equal to n, then we're done with jobs, and then we just return 0. Otherwise, then now we can split. But I do wonder if there's a no. No, that doesn't make sense. I was going to say, I wonder if there's like a thing, right? One thing that does happen from time to time is that the examples, they will lie to you, and that they'll tell you like, oh, this is how you come up with the math, but really you could have done it another way, a more generic way, a more general way, and it still gives you the right answer. And I was trying to think, well, if you split twice, then no, and then start the job, you have 4 workers start the job, you have 3, which you know, maybe it's too much, right? So I don't know. But I mean, split, we would just have, okay, so we got best is equal to infinity, say, right? So that just means it takes you forever. So then to split, yeah, best is equal to min, best f of, we didn't change the index, workers, we times it by 2, right? And then the cost is per split. And then, you know, one worker, and this is the part, right, is that we take k jobs, right? So it would be k in range from, I don't know, from 0 to n minus index or something. So then you would have something like this. And what's the cost, right? It's going to be f of index plus k, workers minus k, and we need actually, and this has to go at most workers, right? Something like that. I think it's actually workers plus 1, but so we'll just put it here, right? If k is less than or equal to workers, right? And then we could also maybe do like, if workers is equal to 0 and you still have a job, then just return infinity, obviously. So now you have this, and there's no cost. Oh, no, and then you have to do the max from from what was it called, box sub index to index plus k, right? Because you have to get the max. Yeah, because that's the max of these jobs, and of course you can actually do it in a rolling way, but I'm going to keep it like this for now, just to at least test that it is correct for small examples, right? So we have index of 0, 1 worker, right? That means that there's an infinite loop somewhere. So, oh yeah, because you just keep on going, I think, that's why. Okay, so, I mean, yeah, that is obviously dumb. What we want is actually, yeah, if, okay, split workers is equal to workers times 2, and if split workers is greater than, or yeah, whatever, which is greater than n, then split workers is equal to n, because that's just everybody. And then here we just write split workers. It's still infinite loops though, so we just have to do another check of if workers is less than n, then we do it. Otherwise you never split anyway, right? And then this should terminate unless I messed up a constraint. Maybe I messed up anyway. Why is that? Oh, because this, I think it's because I'm going out of the loop or whatever. I think this should be plus k plus 1, because it's, yeah, k should not be 0. I think that's why, because otherwise you're just doing no workers. Okay, so at least it's showing that it's returning infinity, saying that it's not possible, which should not be possible that it is not possible. So I think this needs to be just plus 1. I think that's what I was saying. Okay, so it works for this, it works for this, it doesn't work for this, which means that there's something really wrong, right? Because I mean, we have to obviously maybe optimize it, but it doesn't even work without optimization. That means that everything's just off, right? So it's saying, so okay, so first thing it wants to go is 2. So index 0, 2 workers. Is this plus or max? I think this is wrong, because I mean that is the cost, but it's not a plus, it's a max. I think that's why, because you want it to be, yeah, okay. Okay, so that's right, except for now it times out properly, and we can show that with just like I don't know, and we can, okay, we don't need this anymore. We could just do maybe something like here where just a box is equal to, I don't know, even 1 times 1,000. I think this should time out, because it should be like 1,000 cube maybe. If not, then we're sending it, but it seems like it's timing out, so we cannot do this. But at least we have something that we can base off to correct, right? Let me run it again just to make sure that we're having a good, okay. That is curious. Unless this is like an if statement problem where there's a case analysis, that's maybe my if statement problem. I'm trying to think maybe there's a way to write it backwards, but Alright, so now I can maybe do max. Oops. What's going on? I just want to write max of this. Workers plus 1. right? And then now we can remove this. Huh. Oh, this is min, not max. Oops. Okay, so this is still good. I mean, that's why we wrote it this way. But I feel this is still not good though. Just want to make sure. Yes. Man, I'm so tired today. Alright. I mean, obviously we can also optimize this out. This is just a rolling max, right? So I don't know. Heaviest is equal to 0. Oops. But I don't think that's the difference, right? Well, we'll still write it anyway, because -1, right? Yeah, because if k is 1 worker, then you take only this one. Okay, so then now it's this. Heaviest is in like the heaviest edge. Okay, I mean that's still good. This is still not good, I imagine. Yeah, just comment it out. Alright, so then now how do we optimize? I feel like I needed one more observation. I guess the question is, so I mean the way that you would normally do it is that you take a note of this and do them in a specific order, right? Because basically you're maxing over this. Wow, this is kind of a hard technique though. I wonder if I'm doing it wrong, but yeah, but you might have something like a function, right? So this is split, this is tick, right? And then the tick is that we just because we want to max over oh, because initially I had a plus. I think that's what confused me. But because this is max, what this means is, what does this mean? Because this is max, we can just do it one at a time, right? Because basically if we write it out, what we're doing is that we're just doing the max of f of index plus 1, workers minus 1, f of index plus 2, workers minus 2, max of this and whatchamacallit, box sub index. So then now this box of index plus 1, right? So you have all these, right? And there's no adding. I mean, there's adding here when you split, but you could get there and split, and then you get there and split, right? And because of that, this is just this is just another core of this, right? If you think about it, meaning that we can just write best is equal to min, best, max of f of index plus 1, workers minus 1, and then heaviest. That's hard, isn't it? To kind of come up with. Maybe not. I don't know. Oops. It's not heaviest anymore. It's box of index. We have to check if workers is greater than equal to 1, of course. Okay, let's try the big case. Why is this wrong? Or why does it? I mean, I wasn't surprised if example 3 is wrong. I'm surprised that 1 is wrong. Also, it takes 2.0. Oh, wait. I'm just dumb. I still have this out. Okay, so that means that. That means it takes 2.5 seconds for that long. It makes sense. Yeah. So the idea here is that if you think about this recursively from the perspective of index plus 1, this is index plus 1, this is worker plus 1, and because this is a max, this is fine. If we have to do a plus and then a max, then that's what, or something like that, then that's a little bit awkward. You may wonder if there are duplicate cases where you take tick and then you split and then you tick, but the answer is actually no, because it's like a diamond shaped thing where you just get to the same place. So order doesn't matter. The way that we structured it, I hope. I guess we'll see. We submitted it. Okay, I mean, memory limited is fine. In that it is just a Leetcode thing, and I just forgot to. No, I didn't think I needed it, but I will put it in here anyway. But F. Alright, and we'll see if this will. I mean, that's just a very Leetcode specific thing, but hopefully it gives me the right answer anyway. That is actually sad and surprising. But it's 1,000. I mean, this is definitely 1,000 squared, unless there's like infinite loop that I'm not realizing. So maybe there is a smarter way. I mean, it does take 1.6 seconds, but I don't get it. It's just 1,000 square, right? How can it time limit? I mean, am I missing something here? Like, I'm just trying to think why this could take so long. This is 1,000 square, right? Max and min, maybe. I do a lot of max and a lot of min. Let's use that. Maybe will help. I don't know, to be honest. X is y, O is y. Went from 1.6 seconds to 1.7, so that didn't really help enough. Did we use this one? Okay, so it still works at least, but now it still times out even without the photo. What am I missing? N. Okay. I mean, I guess I mean that still shouldn't do that much, right? I mean, you could do like index, something like this maybe, because that's the number of workers left. But now it's infinite loop. Maybe I did that off by. Maybe there's an off by 1 on this. I don't know, because I mean, this is 2 times faster. I don't know if that's good enough, but the idea being that, I mean, I don't know, I just capped it off a little bit lower, but all right, let's YOLO submit. Just because I don't know, why not? But I feel like I'm missing a case. Like I'm missing an understanding. Okay, so we did get it right. It's very tragic, very sad. Okay, so last time I did a lot of mistakes too, so it's not unique, but I did solve it faster. Or I didn't solve it faster, but I did get to it. What is this? Oh, DP. I guess I did the same thing. I wonder if I came, you know. This is much cleaner. But why does that one faster? Oh, if n is equal to 1? Does that matter? I mean, it is a little bit faster because we used this instead of cache. But I am curious. I mean, there's nothing that I haven't. I mean, this is just bottoms up, right? So yeah, we could have done bottoms up. That's not a big issue, but okay. So, I mean, I guess this is right. It's just that we didn't do bottoms up. Let's take a look at the hints. There's 6 of them. So, because I'm curious. I mean, maybe I could need it is equal to n minus index. So if we have more than needed, then we don't need to. Right. This is definitely a harder one than I would have guessed. But now I'm curious about the hints. Greedy approach, okay. Try, okay, that's what I've done. DP, do first time, okay. Yeah. Okay, that's basically it. If you choose to split, it's always better to split all the workers you have. Yeah, no. Yeah, of course. I don't know. That those hints don't really help enough. Maybe it does. I don't know. But yeah. Yeah, I don't know. But I think that's all I have for this one. That's all I have for today. Let me know what you think. Thanks for watching. Thanks for supporting. Stay good. Stay healthy to good mental health. I'll see you later and take care. Bye-bye.